In today's world, we are surrounded by a vast network of interconnected devices that communicate with each other to make our lives easier. We call it the Internet of Things, or IoT. With the proliferation of IoT devices, the amount of data generated by these devices has increased exponentially. This data needs to be processed and analyzed to extract meaningful insights. However, transmitting all of this data to the cloud for processing can be time-consuming and expensive. This is where edge computing comes into play. In this article, I will discuss the basics of edge computing, its advantages over cloud computing, and how it is poised to revolutionize the IoT industry. Introduction to edge computing. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it is needed to improve response time and save bandwidth. In edge computing, data is processed locally on devices called edge nodes rather than being transmitted to a centralized cloud server for processing. This reduces the latency and bandwidth requirements of IoT applications, making them faster and more efficient. Understanding edge computing I/O. The Internet of Things, IoT, is a network of physical devices that are embedded with sensors, software, and other technologies to enable the exchange of data with other devices and systems over the Internet. The data generated by these devices can be used to optimize processes, improve efficiency, and create new business models. However, transmitting all of this data to the cloud for processing can be time-consuming and expensive. This is where edge computing comes into play. Edge computing allows data to be processed locally on edge devices, reducing the amount of data that needs to be transmitted to the cloud. Advantages of edge computing in IoT. There are several advantages of using edge computing in IoT applications. One of the most significant advantages is reduced latency. In real time, applications such as autonomous vehicles or industrial control systems, even a few milliseconds of delay can have catastrophic consequences. By processing data locally on edge devices, the latency is reduced, improving the response time of the application. Another advantage of edge computing is improved security. With cloud computing, data is transmitted to a centralized server for processing, which can be a security risk. In edge computing, data is processed locally on edge devices, reducing the risk of data breaches and cyber attacks. Edge computing also reduces bandwidth requirements. With cloud computing, all data has to be transmitted to a centralized server, which can be expensive and time-consuming. In edge computing, data is processed locally on edge devices, reducing the amount of data that needs to be transmitted to the cloud. Edge computing architecture and frameworks. Edge computing architecture is built around the concept of edge nodes, which are devices that are located at the edge of the network and are responsible for processing data locally. These edge nodes can be anything from a Raspberry Pi, a smartphone, a network switch, or a micro data center. Edge computing frameworks provide a set of tools and services to manage and orchestrate the deployment of edge nodes. Some popular edge computing frameworks include Oz Greengrass, Azure IoT Edge, and Google Cloud IoT. Connectivity challenges and solutions. One of the biggest challenges of edge computing is connectivity. Edge nodes are often located in remote or harsh environments where network connectivity may be poor or non-existent. To overcome this challenge, edge nodes can be equipped with local storage and processing capabilities, allowing them to operate independently even when network connectivity is lost. Edge nodes can also use edge-to-edge communication protocols, such as MCTOT or CoAP, to communicate with each other in a peer-to-peer manner. Edge computing trends to watch out for. Edge computing is a relatively new technology, and there are several trends that are shaping its future. One of the most significant trends is the use of artificial intelligence, AI, and machine learning, L, at the edge. By bringing AI and ML to the edge, it is possible to process data locally in real time, enabling new use cases such as predictive maintenance, anomaly detection, and intelligent automation. Another trend to watch out for is the use of edge computing in 5G networks. 5G networks promise to bring ultra-low latency and high bandwidth to IoT applications, enabling new use cases such as augmented reality, virtual reality, and autonomous vehicles. Edge computing can play a critical role in enabling these use cases by bringing computation and data storage closer to the user. Real-world examples of edge computing in action. Edge computing is already being used in several real-world applications. One example is in the oil and gas industry, where edge computing is used to monitor and control remote drilling sites. By processing data locally on edge nodes, it is possible to improve the response time of the application and reduce the risk of downtime. Another example is in the healthcare industry, where edge computing is used to monitor patients in real time, enabling early detection of health issues and reducing the risk of hospitalization. Key players in edge computing market. There are several key players in the edge computing market, including cloud providers such as Amazon Web Services, Microsoft Azure, and Google Cloud, as well as hardware vendors such as Dell, Hewlett-Packard, and Cisco. Startups such as Foghorn and Eradata are also making waves in the edge computing space, providing innovative solutions for edge computing. Edge computing vs. Cloud computing. A comparison. Cloud computing and edge computing are two different computing paradigms with their own advantages and disadvantages. Cloud computing is ideal for applications that require massive scale and centralized management, such as social media platforms or e-commerce websites. Edge computing, on the other hand, is ideal for applications that require low latency and real-time processing, such as autonomous vehicles or industrial control systems. However, edge computing is not a replacement for cloud computing, but rather a complementary technology that can be used in conjunction with cloud computing to provide a complete solution. Conclusion. Edge computing is a game-changing technology that is poised to revolutionize the IoT industry. By bringing computation and data storage closer to the user, edge computing can improve the response time and efficiency of IoT applications while reducing the bandwidth requirements and security risks. With the advent of 5G networks and AML at the edge, the potential of edge computing is only beginning to be realized. As such, it is important for businesses to stay up to date with the latest trends and technologies in edge computing to remain competitive in this rapidly evolving market.